Let's sketch the surface z squared minus x squared minus y squared over 4 equals 1. If you refer back to the 6 basic quadric surfaces, you can find the form that this most closely resembles, and it is, you can identify it as a hyperboloid of 2 sheets. All of the terms are squared, all of the variables are squared. The z is positive, the x and y squared terms have negative coefficients, so it looks pretty much just like this hyperboloid of 2 sheets. To sketch the traces, we'll start off with the xy trace. For the xy trace, you let z equals 0. Your equation is negative x squared minus y squared over 4 equals 1. If you try to multiply everything by 1, by negative 1 to get rid of those negatives, you get the equation that's in the form of x squared plus y squared over 4 equals negative 1. Now it looks like an ellipse, but in fact it's not an ellipse. It has no solution. There's no trace, because there is no way that if you have any value squared, you're always going to get something 0 or positive. If you add those together, there's no way that it could equal a negative 1. So there's no trace in the xy axis, xy plane. Our next trace would be the, let's do the xz trace. To find the xz trace, you let y equal 0. Put that into the original equation, and when you simplify, you get z squared minus x squared is equal to 1. This is in the form of a hyperbola. This is in the form, we can think of this as over a squared over b squared. It's in the form of a hyperbola, but a and b would both be 1. So you can sketch a hyperbola on the xz plane by drawing the representative rectangles. The A would be 1. That means in the z-axis, let's label this your x-axis and your z-axis. In the z direction, you're going to go up 1 unit, and you're going to go down 1 unit. And in the x direction, it's x squared over 1, so b would also have to be 1. So you're going to go to the right 1 unit and to the left 1 unit, and you draw a box here, and the diagonals of that box end up being your guidelines, your asymptotes for the hyperbola. We can sketch the hyperbola opening up around the z-axis. It will look something like this. That's the hyperbola, which is your xz trace. Now let's find the last trace would be our yz trace. Our yz trace. And to find the yz trace, you're going to let x equal 0. The equation that results from that is z squared minus y squared over 4 equals 1. This is another hyperbola. So to sketch this, I'm going to draw that rectangle where you go, we're going to label this, the horizontal axis is your y-axis, vertical axis is your z-axis. You're going to go 1 unit up and down in the z direction and 2 units to the right and left in the y direction. Draw that rectangle, and the diagonals of that rectangle are your asymptotes for your hyperbola. It's going to open up around the z-axis. So you have the top and the bottom branches of the hyperbola when the yz axis, yz plane. Let's put those all together on a 3D graph. X-axis, y-axis, and z-axis. The xy trace For the xy trace, there is no trace. It's not going to go through the xy plane. For the xz trace, you're going to go up 1 and down 1. Now, I don't need to draw the big box or anything, but you can expect this to be a hyperbola that opens up and down in the xz plane, and then the hyperbola that opens up in the yz plane is much wider. Okay, I know that doesn't look as nice as what you have up there, but you can imagine that you have these hyperboloid of two sheets, kind of a bowl that's opening up and a bowl that's opening down. So this is a hyperboloid of two sheets by hand using the trace method.